So in the next section, we learn here about potential energy. And in particular, in this section, we're going to do gravitational potential energy. Okay, potential energy is associated with the position of the object within some system. So it's a property of a system, not of an individual object. Okay, a system usually contains maybe more than one object. So it's the position of an object with respect to another object. Okay, or with respect to several other objects. So a system is a collection of objects interacting via forces or processes that are internal to the system. That has to do with potential energy. So we talked in chapter 4 about conservative and non-conservative forces. And for every conservative force, you can define a potential energy function. Okay, so conservative forces are associated with a force field. And depending on where the object is in the field, it has a certain potential energy. Okay? So evaluating the difference of the function at any 2 points in the object's path gives the negative of work done by the force between those 2 points. And we'll see that in a minute. So gravitational potential energy, what's our system, first of all, in this case? We have gravity is our force field. So gravity in terms with reference to the Earth, when you're close to the Earth's surface, you're talking about a system that contains the Earth and our object of interest, whether it's a person or it's a book or some kind of object. Yeah? So it's the relative position of that object with respect to the Earth. And we can define any position, any configuration as our zero potential energy. It's common to take that zero potential energy at, say, the surface of the Earth. So right where we're standing. So if we lift an object above the surface of the Earth, it automatically gains gravitational potential energy then. Okay? So here's an example. Here's the surface of the Earth where we define our potential energy to be equal to 0. So we can write that here. Our potential energy reference equals 0. At this point, okay? And as you lift an object up, say till here, it gains a potential energy. And how much energy does it gain? That depends on the height it has risen. So if that height is some final yi, let's say some initial position, then some distance y, then we have done work against this gravitational force, which is mg, and we have lifted it a distance of y. So mg times y is going to be the work done, which is going to be the amount of work that we need to do to lift this book. Since it's a conservative force, we can recover all of that energy, yeah, that went into doing the work. So mgy or mgh, as this is conventionally, the height is written as h. So you might see the formula mgh. In this example, it's mgy, y being this entire distance here. That's the potential energy for this book at this higher position. Now, let us say you let go of the book at this position, and this is its initial position, and it's going to fall. And let's consider a position while it's falling as its final position. So then the new height at this point is this height, yf. Yeah? So the amount of energy that it has lost, or the work that it has done to fall from here to here, is the change in height, delta y times mg. Yeah? Delta y is yf minus yi. So mg times yf minus yi, and it's the negative of this. So if the book is falling downwards, then yf is lower, a smaller number than yi. This term will turn out to be negative, and the work done will be positive. Since the force and the displacement are both downwards, the work done by gravity will be positive. Huh? Okay. And that work will be in joules, just like energy is in joules. So work and energy are interrelated, very closely related. Okay. So what did we say? We said that we need to define a reference level for gravitational potential energy. That's where we set our potential energy to be 0. You can define it to be anywhere in your program, but once you set it, you cannot change it when you're doing your calculations, okay? So a location where the gravitational potential energy is 0 must be chosen for each problem. The choice is arbitrary, okay? Since it's the change in potential energy that we are most interested in. Once the position is chosen, it must remain fixed during the problem. Choose a convenient location for 0 reference height, often the Earth's surface, but sometimes it may be some other point, okay?